Are you willing to write a code for the DISP subroutine in Abaqus for a simple example within 10 minutes? Even if you haven't worked with programming before, you just need to watch this video and follow it step by step. In this example, as illustrated in the figure, we have a circle. A displacement is to be applied along the circumference of the circle, consisting of two components in the x and y directions as indicated in the figure. The displacement is applied linearly over a period of 1 second. Due to the limitations of Abaqus in applying such boundary conditions, we utilize the DISP subroutine. First, let us explain how the DISP subroutine should be written for a project like this. To start, we copy the subroutine interface from Abaqus and paste it into a new text file as shown in the video. Now, based on the problem conditions, we need to insert our code into the subroutine interface. To make coding easier, the first step is to save the code in a file with the Fortran format, or more specifically, with the .f extension. First, we apply the boundary condition in the x direction. To do so, first we need to check if jdf is 1. Now we define the desired equation. The only thing to note is that here, coords gives us the coordinates of the point. Moreover, time, 1, represents the total time. We use it because the displacement ramps linearly from 0. Now, to define the boundary condition in the y direction, we check if the degree of freedom is 2. If it is, we need to define the equation for the displacement in the y direction. It's done. That's all. Now, we close the if condition and save the file. Now that you've successfully written the first DISP subroutine, we can move on to Abaqus. Use this subroutine for the analysis and check if the displacement aligns with our expectations. Let us create a job. Here, you need to load the subroutine file that you saved with the .f extension. Now we submit the job and allow the analysis to proceed. Let's go check the results. Here, you can plot the displacement field and display the contour on the deformed shape, or simultaneously on both the deformed and reference shapes. For validation, we plotted the displacement equation in Excel. As we can see, the deformation pattern matches the Abaqus results, which confirms the accuracy of our work. Since the problem is quite simple, there's not much complexity involved for Abaqus modeling. You can continue watching the video to observe the modeling process in Abaqus. However, while you're watching, I'd like to point out that this was just an example. If you're interested in learning the fundamental use of the DISP and VDISP subroutines and becoming familiar with all their components and variables, you can visit our website and explore the package we've created on this topic.
The link is provided in the description.
Additionally, within that package, we offer several other workshops where we explain how to write Fortran files for various boundary conditions. Furthermore, in the suggested package, you'll have easy access to all the IMP, ODB, and Fortran files for the models. Further details about the suggested package and how to access it are provided in the caption.